So my design for our independent project was essentially Christmas lights, which sounds quite simple, but it was actually subtly complex. Now, if you'd like to see here, I'm using two 555 timer ICs, and that's so I can generate two different square waves. Okay, these LEDs here are respective to that 555, and these LEDs here, up here, sorry, I need to use a pointer or something. Those LEDs up there, the red and the blue, are respective to this 555, okay? So what's going to be cool about that, I'll show you here when I plug it in. So with this potentiometer and it's how it relates to this capacitor will determine the speed at which these are altering. So if I wanted to speed this one up down here, let's try and match it to about let's try to synchronize it there. Right. Seems to be going a bit slower, so we're gonna turn this resistance a little this way. Now they're just about matched, aren't they? Seems the duty cycle is a bit to where the output for the yellow is longer than this one. There's a way to alter that as well. But anyway, now if I wanted to reset it, I could plug the reset to ground, or I could also just unplug the whole circuit back in. Now they're just about synchronized. Anyway, so the way this works is that not only does this 555 timer control the lights, but it outputs a square wave. And a square wave has a high voltage, then a zero voltage, over and over, forever and ever. Now, the way I got this to light up when this one isn't lit up is that I connected it to what was essentially a NOT gate. I made an inverter circuit with MOSFETs. These are 2N222As. And if you see here, out of the collector, if there's no applying a voltage to the bases here in the centers, so the centered pin here, that will allow the emitter to all right. Hold on. Okay, yeah. My apologies. I was getting kind of confused because I typically use BS170s, which have drain gate source terminology. These are 2N222As, and they are based off of current rather than voltage like the BS170s. But when this when the 555 outputs high, the current runs through straight from the base it runs into the base and allows the power from the rail to run straight to the emitter. Now, what that does is it means that this is acting as a switch. So the current doesn't care to go through this LED at all when this is outputting high. But when it's outputting low, the switch is kind of open. And so the current is traveling through this resistor, through the leg of the collector here, and through the LED. So that means when this is low, i.e. when this is off, or when this is off, these guys that are set to be tied to their inverters are turned on. So if I wanted to, again, I'd change the rate. Do it down here too. You put this to music if you wanted. Make a cool Christmas light display that goes along to our favorite Christmas song, All I Want for Christmas Is You by Mariah Carey. It's everybody's favorite Christmas song, right? Looks like try again to get them synchronized. can reset it. So they start at the exact same time. Oh, looks like that one sped up again down there. This guy's a little finicky, this potentiometer. Anyway,